piecewise functions. The point of piecewise functions is to define a function differently over different intervals. And here's a better example than the one I did in class. I start driving from 0 miles per hour, so I'm at rest at 0 miles per hour, and I accelerate to 25 miles per hour in 10 seconds. Okay, so this shouldn't be too hard to imagine. For the next 10 seconds, I drive at 25 miles per hour. Then, let's go to blue, then I come to a stop over the next 3 seconds. So I circled these in red and for a reason. Let's talk about intervals. Up here I do mention define a function differently over different intervals. And if we think about the time being in intervals, from t greater than 0 but less than or equal to 10 seconds, and I'm just going to write it over here, I go from 0 to 25 miles per hour. And then let's go to green, for t, and I shouldn't say greater than or equal to, let's just say as soon as a split second after 10 seconds, I stop accelerating and I'm traveling at 25 miles an hour, but it's really for the next 10 seconds, so up to 20 seconds. My speed is an even 25 miles per hour. Then I come to a stop, and we're blue now. Then I come to a stop over the next 3 seconds. Well, we're already up to 20 seconds, so from the 20th second up to the 23rd second, I go from 25 miles per hour to 0. I should write seconds over here. Now, how do we look at this graphically? Graphically, there's going to be color too, so don't worry. So how would we look at this graphically? If you've taken physics, we very typically like to look at t on the horizontal axis, and we're going to put speed up here because the way it was presented. I mean, I didn't ask you to graph speed versus time, but it'll be clear why this will make the most sense. So from t equals 0 to 10, my speed goes from 0 miles per hour up to 25. And it stays there. It stays at 25 miles an hour for the next 10 seconds. So that's from 10, so I'm going to write 10 to 20. And then I come to a stop over the next 3 seconds. I didn't say that I decelerated smoothly, or accelerated smoothly, but maybe it's implied. So 20 to 23 seconds. And I should put the intervals down here also. I'm just going to do it in like a dashed red, and a dashed green, and a dashed blue. But this describes my speed. I went from 0, 25, staying at 25, staying at 25, staying at 5. After 20 seconds, I decelerate, and this point is 23. I should make sure this is 23 seconds over here. Now, if they said now define this function, there's the given. You can always go back to look at that again. How would we describe this function now? Speed is a function of time. Now I'm going to define each one of these parts of the graph over each of them, and I'll just keep with the colors. So from t is greater than 0 but less than or equal to 10, this is just a straight line, and the slope is 25 over 10. Right? That's rise over run. So I'll do it out the long way. And then the intercept is 0. So 25 over 10 x. And I'm going to reduce this in a second, but this is or I'll let you reduce it, but this is the general idea. From 10, did I change greens on you? 10 is less than t, but still less than or equal to 20. How would you describe this function right here? That's just staying at the height 25. And from the next interval, from 20 less than t, which is less than or equal to 3, it's this straight line. And now, this is the nice part of the equation for lines. We could put this in mx plus b form, but we do have a point and we do have a slope, right? If the slope, well, let's first find a point on this line. It's right here. We could use 23, 0. So I'm just going to do this in blue. This is 23, 0. What's the slope of this line? Well, it's the, and I'll do that in yellow, it's the rise. Didn't it sink 25? Minus 25 over the run, which we can read right here is 3. So what's the equation of this blue line from, from 20 to 23? It is y minus y1 is equal to negative 25 thirds x minus x1, which is 23. And I'm going to leave this as it is because I'm out of time. Well, I'll do it. Maybe I'll do it really fast. Let's just do some style points here. Let's write this in a good way here. S of t. If I get cut out of time, I'll maybe continue another one. Here, 25 tenths is the same as 5 halves. X from 0 is less than t, which is less than or equal to 10. For t is greater than 10 but less than or equal to 20. Oops, that should be green, right? It's okay if this is all black in your or in pencil. Less than or equal to 20. We're at this point 25, and let's just rewrite this here in blue. Y is equal to negative 25 thirds times x minus 23. Perfectly acceptable answer for, this is just in point slope form. For 20 is less than t, less than or equal to 23. And I'll do another example in a minute, I hope.